Hello dear students, in the last video we have seen that matter undergoes conversion, that is interconversion, and it is because of the two factors, it is temperature and pressure. Now today we will see the effect of change of temperature. What happens when the temperature change? Now what takes place when the temperature change? Either if heat increases, temperature increases. If heat decreases, temperature decreases. It means the temperature increase or decrease. But now how we will come to know for particular substance that how temperature is increased and how temperature is decreased. We feel hot. We are human beings. We can speak, we can feel, we can understand. But if we are taking a laboratory experiment, how the substance, how the matter will feel that temperature is increased or temperature is decreased. So, by looking some of the phenomenon, we'll come to know that temperature is increased or temperature is decreased. So, one of the measurement device which is used in the laboratory is the thermometer. We can say lab thermometer. So, temperature change is measured by lab thermometer in degree Celsius. Now, when we go to the doctor also measures our temperature, whether we are having high fever or we are not having fever or we are having normal fever, but laboratory thermometer is not used to measure our body temperature. For that, clinical thermometer is used. Clinical thermometer measures the temperature in degree Fahrenheit. Lab thermometer measures the temperature in degree Celsius. Degree Celsius has the range of minus 10 degrees Celsius to 110, positive 110 degrees Celsius. Whereas, if this Celsius is converted for the form Fahrenheit, it is only 32 degrees Celsius to 45 degrees Celsius, very narrow range, which is converted as Fahrenheit. Now, all over the world, the different countries started measuring their measures in Celsius, some started measuring degree Fahrenheit, but scientist Kelvin has made one standard thermometer, and that standard thermometer scale is termed as Kelvin scale, and the temperature change is measured in Kelvin, which is considered as standard unit, SI unit, that is International System Unit of Temperature is Kelvin scale in capital K, which is not written as degree K. You must remember, whenever we write temperature in Celsius, the unit is degrees Celsius. Temperature in Fahrenheit is degree Fahrenheit, but temperature in Kelvin scale is always written as only capital K and not degree K. What is the combination or comparison in Celsius and Kelvin? Degree Celsius is equal to 273.16 Kelvin, which is round up and considered 273 Kelvin. Right? Now, effect of change of temperature will continue with the first. If the solids are given heat, now see, whenever a substance is given heat, what happens? Temperature increases. Kinetic energy increases. Particles overcome their force of attraction and starts leaving the position. I would like to explain one simple example. If you are all kept in one classroom and the number of the students are think that you are 30, then from another class also 30 students are brought. One more class, 30 students are brought into the same class, and that all the windows and doors are closed. and even you are not allowed to put on the fan. And you are asked to remain in this class for a while. What happens? For some time, you are able to sit wherever you are. After some time, you people will stand up and start moving from one place to another because whatever the temperature is there, it is increasing. Why increasing? Because no air is coming from, fresh air is coming from outside, as well as there is no working fan, and you people are respiring. So there is also exchange of gases, and due to this the heat increases, and due to that you are all started moving in the class from here and there. That means particles starts moving with the kinetic energy, and these particles try to overcome. They will try to overcome their forces among themselves. In the substance also this takes place, and so what happens? They leave their position. They will try to move away from their position and will reach a particular stage. A particular point will be reached and they will start melting. And at this point when they start melting, that is called melting point. And the whole process in which solid converts to liquid because of the change of temperature is called fusion or melting process. Now, let me explain this by the example of ice cubes. Ice cubes are taken and heat is given to it. Do we think that sudden temperature will change? No. Sudden temperature will not increase. Still, it will acquire the heat within the particles, and these particles will supply the energy. Which energy? Heat energy. And this heat energy will start getting the ice cubes to melt, and thus they will start melting to the water. So the question is here that as soon as heat is applied to it and suddenly temperature does not change, but how this is explained and how we are able to understand this? Because this heat which is applied to cube ice and it melts to the water, then that heat energy is termed as latent heat of fusion. So what is latent heat of fusion? Please pay attention. I have shown a diagram. Here I have taken a beaker in which ice cubes are there. I have given heat from here. Pay attention. As soon as it is given from here, heat will start taken by those crystals which are at the bottom. The temperature which is standing here, which is made to stand here in the laboratory, you can see this arrow. The temperature here is 0 degrees Celsius. Now, because of this heat, the crystals starts melting. So each crystal's particles will acquire the heat and will start melting by supplying this heat to the other particles also, because we know that particles have attraction among themselves and their attraction force breaks because of the heat energy increases, kinetic energy increases. So what happens here? These crystals you may see here, some of the crystals now already have melted and some are still there. But you see the temperature of this thermometer, it is there only. Then the question is, heat is continuously given. Why there is no rise in the temperature? Where the heat has gone? And here you see, still heat is continued. Now, most of the crystals are melted and temperature has risen. So, the heat which is acquired by each particle, until and unless each particle is not acquiring that heat, then the melting is not possible. So heat which is within the particles, it is hidden heat, and this hidden heat is called latent heat of fusion. Latent means hidden. So hidden heat within the particles is called latent heat of fusion. Right? In the same way, liquid when heat is given, temperature increases, kinetic energy increases, particles which are having attraction force will start breaking their force and start moving very faster. And due to that, they also reach at a point and starts vaporization. Right? This is evaporation, where liquid converts to gas because of temperature change. And as soon as the complete liquid starts boiling, the temperature change, and that temperature is called boiling point. Here also the same question is there, that latent heat of vaporization. Water if taken and if it is heated, water consists of bulk particles. It is considered as a bulk phenomenon. Evaporation is a bulk phenomenon. So bulk particles present in the water, that means the particles in the more number, they will start acquiring heat within the particles, and particles of the water will start moving faster and faster, and they will start moving towards the surface of that container. That means blow up and start vaporizing. This vaporizing starts as soon as the particle starts coming to the surface, and then the boiling takes place, which is termed as boiling point. So here also one diagram I have taken. A water is heated and temperature here you can see it is somewhere in the mid. Now as the temperature has still increased because of the heat is still going on, you can see those particles from the bottom acquired heat, pass their heat to the upper particles, and from the surface the vapor has started, that is evaporation. But here there is no change in the temperature. So the same question as here, where the heat is going? The heat here remains hidden until and unless all the particles of the water is not acquiring heat energy. And as soon as all the particles acquires, they will show the change in the temperature. Here you can see it is showing at the top, right? So, and then the vaporization starts very fast. This hidden heat is considered as latent heat of vaporization. So, what is latent heat of fusion and latent heat of vaporization as a standard? As a standard, the amount of heat energy required to convert 1 kilogram of solid into liquid is termed as latent heat of fusion, and the amount of heat energy required for 1 kilogram of liquid to convert into the gaseous form is termed as latent heat of vaporization.